Properly applied, science and technology can take you just about anywhere.
Go ahead and start.
At Disney World, it can put you on a magic carpet and send you back to Aladdin's ancient Agrabah.
Here at the Johnson Space Center in Houston, it can take you on a space shuttle, straight into the future.
So far as her eyes, ears, and mind are concerned, Air Force Lieutenant Colonel, astronaut Susan Helms is operating the robot arm of a space shuttle. Computer simulation makes the practice shuttle just as real to her in Houston as Aladdin's Magic City was to the little girl at Disney's virtual reality laboratory in Orlando. Air Force pilots train with systems like those every day. Hello, I'm Jim Slade, and welcome to New World Vistas, a look at the science and technology of the coming century and how the United States Air Force is using it now. In 1997, the United States Air Force will be 50 years old, an amazing half-century just in the technological growth it took to come this far. But the people you'll meet in this program are thinking about the next 50 years, and some of their ideas are startling. Military aviation has relied on science and technology since the beginning, of course. Its research and development arm has produced some of the world's most advanced air and spacecraft. You'd expect that. Flight is a science in itself. None of that will change in the next decade or in the decades to come. But we're in an extraordinary period right now. There's a rapidly accelerating pace of development. Computer technology is doubling its power per dollar every 20 months. That means that over the past 30 years, there has been a million-fold increase in capability. And the technology is becoming so cheap that virtually any country can have it. What that amounts to is a revolutionary change for all of society based on its surprising new capacity for collecting, sorting out, and using masses of specialized information almost instantly. The information revolution. With such power at its fingertips, today's premier Air Force does more than fly and fight better. It knows its opponent's capabilities and how it plans to use them. And it depends on having superior technology in reserve. With such capability, that Air Force should be able to shut its enemies down, ideally without firing a shot. Although shots were fired, the core of such technologies appeared in the Persian Gulf War, Desert Storm. So-called smart bombs were delivered to very specific targets. Some navigated to the targets themselves. Communications and computer networks were disrupted. Satellites pinpointed the enemy's movements and equipment. Airborne observation posts guided planes to their targets, and there were fighters that were practically invisible to radar. The chief of World War II's Army Air Forces, General Henry Hap Arnold, once told an audience that World War I was won by brawn. World War II was won by logistics. And he said, World War III, if it ever comes, will be won by brains. There are those who believe that Desert Storm proved his point. They use the term hyperwar to describe the startlingly brief air and ground assaults that decided the matter.
In that conflict, the coalition was able to impose strategic paralysis on an enemy state in a matter of minutes. That same level of effect in World War II took years to accomplish. Technology gives us that capability to compress the time factor and to increase the order of magnitude of the intensity of our first attack. Technology separates hyperwar from everything that came before it.
But it took months to prepare. By the lights of those who study these events, that will have to improve too.
The Gulf War was only a shadow, a glimpse of what the possibilities are. We took several weeks in order to conduct the operations that were necessary to achieve our objectives. Far too long. Within 5 years, 10 years, certainly within 20 years, well, to be talking about several days or several hours to accomplish everything that we want to accomplish against a particular country or enemy or environment of one sort or another.
The foundations for such thinking were laid 50 years ago. An aviation pioneer in his own right, General Arnold and his friend the aerodynamicist Theodore von Kármán are considered the architects of American air supremacy. Arnold was introduced to air power in 1911 when he was reassigned from the 29th Infantry to the fledgling U.S. Air Service. At Dayton, Ohio, he was taught to fly on one of the Wright brothers' latest machines. Kármán came to the United States from his native Hungary in the late 20s to teach and work in the new field of aeronautical science. He was already celebrated as one of its leading authorities. The two met and became friendly in the 30s. One of their first project collaborations was JATO, Jet-Assisted Takeoff. Kármán literally broke ground on the idea when he and others from Caltech attached 6 small rockets to the underwing of an Army aircrew. World War II tightened the bond. When it was finally clear that the Allies would win the war, Arnold asked von Kármán to lead a so-called scientist invasion of Europe. Arnold wanted them to follow advancing Allied armies, locate, evaluate, and seize important scientific materials before the vanquished enemy could hide or destroy them. Von Kármán organized what was to be called the Scientific Advisory Group. His friend and colleague, Dr. Bill Sears, says Kármán had no recruiting problems.
Kármán's relationship with all these people was such that he only had to say the word, and whether they wanted to or not, they came and served on the Scientific Advisory Board. He had that kind of rapport with pure mathematicians and physicists, chemists, geologists, people in all fields. Nothing like limited to aeronautical engineers.
And when D-Day was on the horizon, Arnold gave them their marching orders.
I think that you people here are entitled to a little bit of background on this thing that we call air power.
As the Allied forces rolled across France and Germany, von Kármán, his scientists, and a group of Air Corps engineers followed in their dust. Dr. Guyford Stever says he and his colleagues wasted no time.
It was very clear that just plain looting and so on would eventually ruin some targets, so you wanted to get in right just as soon as you could when a target was opened up. But then there was also a race with the Soviets to some of the targets.
The stakes were high, the prizes handsome. The Germans had done extraordinary work on rockets, rocket planes, and jet fighters, and the Americans were anxious to get their hands on them. This Me-262 jet was seized intact at Lechfeld. 9 more were rounded up, plus several damaged planes that could be used for spare parts. As soon as a team of American pilots learned enough to test and fly the aircraft, most were shipped to laboratories in the States where engineers working on an American prototype were eager to see the planes for themselves. Von Kármán's group even found a workable jet helicopter. German engineers had worked out a way for the engine's exhaust to thrust back from the tip of the helicopter's rotors. German rocket scientists had produced boosters and guidance mechanisms that already had left their mark, particularly in England. Ready-to-fly samples were seized and shipped off immediately. The Nazis had built huge wind tunnels in which the Americans found advanced work in development of the swept-back wing. Until that time, most aircraft wings had a straight leading edge to produce maximum lift. This wing foil, found in the wind tunnel at Völkenrode, was designed to be used in the German rocket program. Its back sweep provided more efficient flow of air across the surface, resulting in less lift, but better use of fuel and more speed. It was also ideal for jet-propelled aircraft. One of von Kármán's group, the Boeing Company's George Shire, took a good long look.
Then he sat down and composed the cable back, which is very famous, sweep back the wings of the B-47, data follows. And I have to tell you, and that's of course famous in the Boeing literature, but I was sitting there watching these people in their excitement.
It was a historic moment that set the standard for every jet wing to come.
The American scientists and engineers were already committed to a swept-wing future, and the discovery of German swept-wing research confirmed for them the choices that they had already undertaken.
As early as 1941, Arnold had toured Allied facilities in Europe and had been concerned at the scientific strides he saw other nations making in contrast to the United States. His scientist invasion, called Operation Lusty, only confirmed his fears.
When we saw how the scientific establishment of the Third Reich had served that nation, and what Nazi Germany had been able to come up with, I think it reaffirmed this lesson in Arnold's mind that the United States, in an atomic era, in a jet era, in a rocket era, could not afford to take second place behind other nations.
So, the Scientific Advisory Board?
So the Scientific Advisory Board, and indeed the whole building of a strong scientific and technological tradition within the Air Force.
The Scientific Advisory Board became a permanent institution as the war ended 50 years ago. Since that time, the board has been on call to the Secretary of Air Force and the Chief of Staff, periodically reporting on developments that will be useful to the service in the coming years. Members of the board met here most recently at the National Academy of Sciences Beckman Center at Newport Beach, California, to write New World Vistas, its latest update on technologies currently available and those expected in the next 30 years. In the report, they detail oncoming programs that may fit the Air Force's needs, and they express concern over the way the Air Force does business. Some observers will call the report a radical document. Dr. Gene McCall is the board's current chairman. He will not.
We are not trying to sell the Air Force on change for its own sake. Nobody is interested in that because it's been a very successful organization. But I think what we are saying is that the demands of technology will force changes in the structure, will force changes in the way we think about weapon systems, and that ultimately will force changes in the way that we think about organizations and applications of technology.
Including where the Air Force gets what it needs and who builds it.
There's the 100-foot call out at about 50 feet. There's flare.
Computerized airplanes, transistors, advanced communications, medical technology, advanced computer systems, better and more powerful microchips, surveillance, sensing, and information gathering have all sprung in part from military need. And it's been traditional that sooner or later, components or even whole new military systems will find their way to the civilian market, often as something the original designers never intended or even considered. Development of the jet engine was pushed in the 30s and 40s to make warplanes faster. Before anybody bought it as an airliner, the 707 proved itself as a military tanker. Radar was a military necessity. The British used it to scan the English Channel for attacking German forces. Computers had early military significance. The first really portable systems were developed for spacecraft. Sometimes, outside interests consider private use of Air Force research even before it's fully developed. Here are some examples. In the Armstrong Laboratories at Wright-Patterson Air Force Base, this F-15 pilot may have taken a step into the future when he agreed to try to steer a jet simulator with the electrical impulses of his brain. With some coaching from research engineers and a little practice, he was flying the simulator through hoops on that gigantic screen in about 15 minutes. This woman is balancing a simulator with signals from her brain. Trying to line up or separate the bars on this gauge, she increases a specific part of her brain wave to roll in one direction, decreases it to go the other. Still in its infancy, the research holds promise for future aviators since theoretically, it could allow pilots who already have their hands full to give the airplane's computer even more instructions, such as which weapons to select. The challenge is to learn which part of the brainwave does what, and to build a processor that can read it even when the pilot is under stress. It's a tall order, and any useful results may be a long way down the road, but
I think that we actually have nearer-term applications for a lot of this technology for people with disabilities or various kinds of handicaps than we will see in the military environment. Because we can right now use this to turn a light switch on and off, to move a cursor up and down on a computer, simple things like that. And for some of those kinds of things, if you make an error, if it takes a little bit longer to do it, it's not a problem. To really put it in a cockpit and have it finely tuned and honed and resistant to noise and stress, that's a bigger job. We think we can do that as well, but I think the near-term application for this will be for the disabled.
an important question is, does it take a special person to do it?
I think the answer to that is that with training, many people can do it. It involves the basic principles of biofeedback, and then clever signal processing, and most importantly, matching the technology to a doable task.
Here's something else, a full-body laser. As the 4 laser heads scan down the subject's body, they read every nook and cranny, feeding back an explicit image that can then be used to make form-fitting flight suits, helmets, or other equipment. This scanner measures the head and face so intimately that technicians could tailor an oxygen mask that would never leak, or a helmet that would fit like skin. Medical scientists already see other humanitarian applications, such as this plastic mask. Working with patients who have severe facial burns, researchers have wanted to make a plastic mask that would protect and at the same time guide healing skin back to its natural contour. Casting it would be painful, but on the other hand, a patient would never feel the laser's inquiring stroke, and every last line would be recorded. Ironically, some military technologies seize the civilian public's interest almost before the military fully grasps it. Prime example, GPS, the now famous global positioning system. Now, the Air Force originally designed it to navigate airplanes using a receiver to track the known orbit of a satellite. Lindbergh would have loved it, but the public immediately recognized other uses. The great physicist Edward Teller thinks it would be a great way to track earthquake faults to predict earthquakes. Cinematographer Don Burgess used it to set up scenes for the movie Forrest Gump.
You know, I saw something in this, and it wasn't designed for movie making, it wasn't designed for cinematographers, but it was something that I kind of saw, well, gee, what would happen if I tried using it for this? And it turned out to be a great tool, you know, for the motion picture industry.
Burgess had to find a place to build Forrest Gump's house, where natural light would be best for photographic purposes. The problem? How to predict what the sunlight would be like in that spot when they filmed the movie several months later. His GPS receiver came to the rescue.
The Gump house was built down out of Beaufort, South Carolina, so we found this perfect location with Oak Alley and the long road back to where the Gump house would be. We were able to figure out, when we were going to come back to shoot the scene, where the sun would be in relationship to the oak trees and the river, and actually angle the house so it would best be photographed with the light.
The military's next version will be a super GPS, furnishing three-dimensional instant information on demand to or from the battlefield. No doubt it'll turn out to be a better way to navigate your car, too. It has been that way for half a century. Military needs driving research and development that in turn produces ideas exploitable in the civilian marketplace. Dr. Sheila Widnall is Secretary of the Air Force.
Now, we are entering a transition, I believe, where the commercial sector in many areas has now outstripped the capabilities of the military because of their drive for efficiency, cost effectiveness, reduced cost, and the absolute explosion of applications in the civilian commercial sector. I think the challenge for the military is to take advantage of that, to avoid doing in-house what would be better done in the commercial world, to integrate existing commercial products into our system so that we can save the taxpayers' money and get a better product.
In their report, members of the board agree that it may be time to change the way the Air Force thinks about its needs and about the way it does some of its business. The builder is becoming the buyer. The dramatic changes we see today in communications, information gathering, research and development, even in our leisure time pursuits, have been driven by the increasingly rapid improvement of the commercial high-speed computer.
The commercial sector leads the military in information technology. It's a very strong commercial driver.
In the late 50s, when Lockheed's secret aeronautical laboratories, the Skunk Works, produced the SR-71 Blackbird, the work was done by hand, and design engineering was done with slide rules. There is still no airplane that we know of capable of flying as high or as fast as the Blackbird. But what would it have been like if the Skunk Works had today's computer? In designing its new 777, Boeing used computer technology to put a new spin on building large airplanes that has captured the scientific community's imagination.
It offers automated designs. It has automated flight control systems that have principles which will be very useful in Air Force airplanes in the future. And it's just a different way of thinking about the way that one develops an airplane.
The 777's cockpit looks like a video gamer's dream, and truthfully, it takes a computer-literate pilot to fly it. By satellite, the plane can be in contact with home base and its services from virtually any place in the world. Its flight computers operate as a third crew member, offering the pilots information on a need-to-know basis, even offering a choice of alternate landing fields if such a choice is necessary. The system is pilot-friendly, and it sets new standards in that sense. But it goes beyond that, both technically and philosophically. The 777 was designed entirely on computers. No drawing boards, no paper blueprints. A team of 4,000 engineers was connected to one another through large mainframes in which the plane was constructed electronically before any metal was cut.
We literally simulated every one of the 4 million parts on the airplane, ensured that they would all fit together, that they'd be easy to maintain, be easy to operate in service. We projected this on large movie-like TV screens so that everybody from the airlines to the mechanics to the engineers could see their design, see what they had created, and ensure that it all fit together and it would operate properly.
All adjustments were made on the computers. The first sample they built, rolled out of the factory, and flew. And the process cut the normal development time of about 10 years to 6. But it was a gigantic gamble.
We took a real big challenge on this program. We literally were betting the company. Going out on the first flight, standing out there when that airplane took off was a feeling you can't even explain. There was a tingling throughout your body, and many of us just stood there even after the plane was out of sight with awe that all of this worked. It really worked.
Members of the SAB want the Air Force to understand those developments. Other parts of the commercial world have attracted attention too. It appears certain that the Air Force will make more use of commercial satellite services in areas where security is not a requirement.
A great deal of military communications will be going through space-based communications purchased from commercial vendors. When high-speed data networks are launched in space, for example, from Iridium or Teledesic, the Air Force and the DoD will be major customers of those networks.
It's faster and it's cheaper, and commercial systems are plentiful for communications that don't require security. But there are times when nothing will do but dedicated, well-guarded channels. And that's where the military's secure systems come in.
Alpha Whiskey, this is Vicksburg, taking track, Bravo Alpha 072 at this time with SAMS.
Military operations taking place on the other side of the world can now be commanded from a single control room in the Pentagon or from a base that could be anywhere inside the United States. Commanders can see the current battlefield situation through satellite pictures, through cameras on orbiting remotely controlled aircraft, or in 3D simulation. This system is under development at the David Sarnoff Laboratories in Princeton, New Jersey. The whole battle theater is visible in three-dimensional detail. Again, better and faster computers make it possible, but that does not always mean bigger computers. That's another stereotype that's changing. This is a memory unit developed by the Air Force's Rome Laboratories. Not much larger than a sugar cube, it's capable of storing the contents of 100,000 books. A similar model could hold all the works in the Library of Congress. The growing ability to miniaturize superintelligence systems makes it possible to plug in more and more information resources for the warfighter.
That is, trying to understand from the myriad sources of information and data flowing in from the sensors to the command centers, trying to use automatic methods for creating situational understanding. What is actually happening out there?
To make the sharp end of the spear, the pilot and the airplane, more efficient. None of this comes cheaply. The Air Force had hundreds of thousands of airplanes in World War II. Today, it has about 6,000. But the aircraft are better today. They do more. They require more specialized training, though, a different kind of education for a different kind of pilot. The equipment for training pilots has never been better or safer. Because in today's world, Before you fly them for real, you fly them in computer-generated virtual reality. The pilot who flies the next generation of Air Force fighter, the stealthy, supersonic cruising F-22, will spend a lot of time in a virtual reality world. This simulator provides everything but the dynamic force of the aircraft's motion. The F-22 is a flying computer. To separate friendly aircraft from the enemy, the pilot asks the computer to identify the targets on his screen. He's moving under stealth at supersonic cruise, approaching enemy targets before they know he's there. To target the enemy, who may still be over 100 miles away, the pilot moves a cursor on a screen. So he does not have to move his hands. The cursor button is on the throttle. The press of a button puts the approaching jets on his shoot list. Meanwhile, his airplane's computer is telling his wingman's airplane which targets he's picked silently, so there's no duplication. The computer tells the pilot when to shoot and when to get out of the way. How about that, video gamers? Since the space shuttle is too complicated and expensive to fly training missions, virtual reality is the only way that Air Force Lieutenant Colonel Susan Helms and her fellow astronauts could learn to operate such an exotic and limited-use vehicle.
It's so critical to our training that we actually end up spending hundreds of hours in the simulator preparing to do the work that we're going to do on orbit. And we get a chance to simulate not only the activity that takes place without mistakes or malfunctions, but we also end up preparing all of our malfunction background, all of our malfunction expertise by going and working in the simulators. What I see here in this particular simulator models almost identically to how the actual robotic arm flew on the space shuttle. And this is the only chance I had to practice it before I had to do the real job.
It's a great release, Susan.
Recognizing an opportunity, the Walt Disney Company went to see virtual reality in the laboratories as early as 1987.
You're going to put on this head-mounted display and fly around in the world of Aladdin.
Okay, did you get all that? Look, just nod your head and try to act like you have a brain, okay?
They liked it so much that virtual reality attractions are going into their theme parks now.
You look like you're in need.
Engineers have been trying to make airplanes tougher and more agile ever since the Wright brothers flew the first one. They're still trying, and they're making progress. Here's maneuverability. The vectoring nozzle, a jet engine nozzle which turns like a rudder to give the pilot of this modified F-16 the ability to turn his aircraft in ways that were never possible before. Radical maneuvers that could be of great tactical advantage in battle or in flying into tight, heavily defended locations.
Ow, 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 ow.
Oh, wow. Look at that. Did you see that? Oh, gee. It's 128 degrees alpha. Isn't that incredible?
With the advent of new composite materials to build airframes that can take the strain of even more abrupt, violent maneuvers than that, engineers could someday be left with the choice of setting operational limits to physically protect the pilot, or perhaps removing the pilot altogether. Air Force technologists have already begun a transition to unmanned aircraft, although for different reasons.
The important directions for the Air Force, technologically speaking, is to move in the direction of using this enormous computer power for unmanned or uninhabited aerial vehicles. Since computers and their software are getting more and more capable, and our sensors and instrumentation are getting more and more capable, we have the ability to direct warfare without exposing our pilots to danger.
In some ways, you could do more if there were no requirement to provide for and protect the human aboard the aircraft. Without an armored cockpit and human systems, the airplane becomes lighter, less complicated, and expendable if necessary. But for now, the vision is of an unmanned plane which could circle for long periods over an enemy target, sending back television pictures or sensing the activity there as a satellite does when it passes overhead. The difference is that most satellites go by in minutes. The UAV could hover for hours or even days. The pilot could be far back in another airplane or even in a control room in the United States, flying the plane by satellite or radio relay. This is the newest military UAV, Dark Star, scheduled to begin service in the near future. Eventually, it's believed that UAVs will be capable of carrying weapons and taking the place of piloted fighters or bombers in forward battle areas.
I think it's not inconceivable that as we go into almost the next generation airplane, particularly as we look at something like the JAST that we're looking at as an F-16 replacement. That's an airplane that we will buy over a long period of time, probably 15 or 20 years. The early versions of that aircraft, I think, will be manned. But by the end of that buy, we may very well be buying some of those aircraft in an unmanned configuration.
There are the application of stealth technology, continuing to apply stealth technology to our delivery vehicles, which may in the future not all be manned aircraft, but could be unmanned aerial vehicles, unmanned tactical aircraft, where you take an aircraft system, aircraft size system, and basically drone it like we have in the past, but it can carry more payload.
And there's a civilian side here, too. Remotely piloted vehicles are being used to study land use patterns, watershed areas, crops, archaeological sites, and what have you. They can sample air layers or fly inside storms simply and cheaply with no danger to a human pilot. Technology's like a ladder. One step leads to the next, and as you climb higher, you get a different perspective. Putting together all the amazing things we've seen in this program so far, strategists now foresee battle scenarios that used to be unthinkable outside of science fiction.
I think that it would unfold kind of like this, that somebody is interested in doing something that the United States doesn't like, and they begin to do it. But what everybody will have learned from the Persian Gulf is that if you want to do something, you have got to create a fait accompli before the United States gets involved in it. And the fait accompli, once done, then you can hope that the Americans will say, well, it's done, so we're not going to intervene. So we have got to have the capability to intervene almost instantaneously. So the President says, go, and the Air Force or the Navy or whomever owns air power, primarily responsible for it, sends out a whole group of things which are hypersonic airplanes, they're space-based weaponry, they are long-duration drones that can hang at 70,000 feet or whatever for some extended period of time. Those things all go out, and almost instantaneously they impose some kind of damage or paralysis on everything that is important to the target state, the target organization, in order to drive its energy level down below the point at which it can continue to function. And at that point we say, here are what the peace terms are, we would really prefer that you agree to them, they're fair, etc. But if you don't, you are simply going to stay in a state of paralysis until such time as you agree.
Although the objectives are the same as always, the methods are changing dramatically. Natalie Crawford chairs the advisory board's attack panel.
We view the role of the word attack as changing in the future. In the past, when we've thought attack or expressed that word, it's generally been with destruction in mind. And with the political environment the way it is today, where we have a need to be able to accomplish an objective, a military objective or military task quickly, we need to be able to do it decisively and produce exactly the kind of effect that's required. In some cases, it will be a lethal or destructive effect. In other cases, it will be what some people call non-lethal.
Non-lethal weapons, weapons that shut down armies or governments without destroying them, show great promise.
Non-lethal weapons perhaps represent the greatest advance in the history of mankind. War has always been a political animal. The purpose of killing was to achieve an objective. If you can achieve that objective through non-lethal means, you have made a great leap.
Chris and Janet Morris are two of the country's foremost exponents of non-lethal weaponry. Some of the applications they describe are startling.
Technologies such as the Lawrence Livermore thermal bullet tracker means that as soon as you fire, you become a target, and the enemy can use your fire to send a responding round right back along that same trajectory. And if what you're firing is a mortar on the top of an apartment building on Sarajevo, that Main Street, that we can send a responding missile right down the barrel of your mortar.
Directed energy weapons, powerful lasers, can destroy enemy machinery with a concentrated burst. There's research underway on electromagnetic pulse devices which simply shut down the other side's electrical systems. Others include a sticky foam, which when sprayed on a person or into a crowd makes it impossible for them to move. Some researchers envision ways of projecting holographic images in the sky to disarm the enemy psychologically.
If you can change that enemy leader's mind without attacking the army, you save lives in his country and in your own.
We are now in what futurist Alvin and Heidi Toffler call civilizational upheaval, a chaotic period of adjustment to new ways of thinking and doing things. The rapid and constantly changing development since World War II, the most explosive in human history, makes it almost impossible to see far into the future very clearly. But based on historic needs and the thrust of today's technology, you can picture the possibilities for the Air Force 20, 30, 50 years in the future.
I think clearly we're seeing more standoff, deeper strike weapons, not necessarily aircraft. Clearly space is going to play a much, much larger role in the entire process. But again, I would argue that the central element that the Air Force or any other force will need is much richer and deeper and better information and knowledge. Because you can have the best cruise missile in the world that can go through the smallest window, but you got to know which window to put it in. And you need, therefore, radical changes in our intelligence capabilities.
That means more spaceborne observation posts, more communication satellites, simply more information from more technical resources.
The specific items that I see at the moment are going to be applications in space, applications of unpiloted airplanes, new munitions that have greater destructive power, and overlying all of it, information systems that connect them all together into an integrated whole. They're not going to be these individual autonomous units out there striking targets. They're going to be tied together with an information system. They're going to be directed on a moment's notice from one target to another, and that is going to change the way we think about air power forever.
Whatever the medium, large or small, the ideal is to build a worldwide monitoring capacity so that in theory, even a small force based only in the United States could have nearly instant global reach.
In an environment like we're moving into, where the bulk of our military forces are going to be based in the continental United States, there's a great need for our national command authorities to understand what's going on around the world. And so the sensor systems that we have in space, the various satellites with all their capabilities, provide a presence around the world that allows us to stay wired in.
The Air Force of the future will be able to more convincingly provide no-fly zones, police them, enforce them, conduct blockading and economic sanctions with more capability because of an electronics matrix which will tie directly into the infrastructure capabilities of any targeted adversary.
Before it all sounds too grand or too easy, these and other thinkers habitually remind their listeners that the knife cuts two ways. If the United States can use emerging technologies to subdue its enemies, those same technologies are just as available to the other side.
I can see a near future with proliferated weapons coming out of the former Soviet Union. They're on the market. They're by the thousands of well, what used to be fairly sophisticated weapons, but they're kind of old-fashioned by now. But I can also see a well-heeled dictator going to the Radio Shack and getting the computer, getting the GPS receiver, screwing it on, and now have a weapon that will give us a hard time.
most of these technologies, of which non-lethal systems or information systems are made, are far too proliferate, far too available to be bannable. And attempts to stop them are going to fail because anyone who gets a college education in a scientific field can develop from readily available parts these technologies.
You can knock out our hospitals, you can knock out our banking system, you can fix it so companies can't send money to each other and you can't get your paycheck, you can knock out our power grid, you can knock out all kinds of central information, either information systems or information run systems, and bring this country to its knees. And we are sitting ducks for that.
Especially since our society runs on technological advances more than any other society in the world. That means the U.S. must make a wiser, more imaginative use of technology.
Well, I think it's a person with a deep bench, a country with creative minds, innovative people, being able to prioritize the investments that they make, and that's a very difficult part of this problem. Prioritizing investments, trying to guess what the right thing, or predict what the right thing is to do for the future, something that has the greatest life.
Picking the right horse for the next century's race. The edges of space are no longer a boundary. Step by step, satellite by satellite, space has become and will be an essential field of operations for the modern Air Force.
Space will be the key medium of providing ubiquitous information to our warfighters to carry out their missions at really arbitrarily good accuracy during all-weather, day-night operations. In the future, a global power, as the United States will want to be, the Air Force will support it, to provide capabilities for global power projection, where from space we can exact our military force at any place on this planet.
To do that, you need cheaper, quicker ways to get necessary resources into space. New work is being done both on expendable rockets and reusable vehicles. No matter how impressive or beautiful the space shuttle is, the system is too complicated and time-consuming to support routine day-to-day space operations. McDonnell Douglas has been testing the DCX, they call it the Delta Clipper, which may be the basis for the next big step. Designed to be cheaper and simpler to operate than the shuttle, Delta Clipper, as conceived, would go directly to orbit as a single unit, deliver its payload, and return for a vertical landing on the original launch pad, where it would be prepared quickly for its next flight. But there are other schemes as well, and those visioneers who look to the even more distant future hope for a transatmospheric vehicle, or TAV, that is, a small fighter-like craft which could take off from a runway with a small crew or payload, fly in the atmosphere under its own power, accelerate to orbit, deliver its cargo, and return to the same runway. Such a vehicle could serve as a so-called space outpost, a camp which humans could occupy when necessary, or where automated experiments could be left and picked up later. In the extreme, the dreamers believe that such an outpost could serve as a giant framework on which you could hang solar power grids, astronomical instruments, communication stations, or anything else that would benefit from a relatively stable base that could be visited and serviced periodically. And from there, who knows? Two noted scientists whose experience, accomplishments, and political beliefs are literally generations apart agree that the Air Force would be the logical agency to meet, and if need be, to protect the Earth from extraterrestrial visitors.
If you think about what our first serious contact with space might be, it might be some lifeless object that's 5 miles in diameter and is coming our way at 17,000 miles per second, and it's going to destroy the planet in terms of life. And we need to be able to deal with that, right? And you need a military type of, you need some kind of way to force that off of its course and move it. And if people don't think that's going to happen, they should look at the surface of Mars and the Moon and say, what made all those holes?
When I was 3 months old, in 1908, in the middle of Siberia, Tunguska, a meteorite exploded with 10 megatons and laid the forest flat over thousands of square miles. That happens from time to time. It happens over a city and no city. We know how to prevent it. We know how to predict it better than ever. And we are already looking for such future events. 60 million years ago, an event of that kind wiped out the dinosaurs. We know what to do about it. We can reach out into space in the form of nuclear explosives. We have a lot of energy in very little weight. With that, we can, depending on what approaches, a comet, a meteorite, we can deflect it or break it up. We must know its nature. We must experiment. But I have no doubt that for a limited amount expenditure, we can help to avoid this type of catastrophe in the interest of everybody.
Teller, I think, is thinking of nuclear things. I like a graviton laser, you know, something that you just point at it and it deflects it. That's the nicest way to do it. But, you know, tractor beams work, I think, in science fiction. Something, I mean, those are things that people have to figure out how to make. I mean, if you can imagine it, somebody can make it eventually.
And beyond that, what will be the nature of the Air Force of the far distant future? Star Trek or Star Wars? No one should assume from this program that old standards are going out the window. What's good is good, and it always evolves into something better. The flying wing of the 40s has reemerged in the B-2. Good design elements always show up in later generations. Good ideas expand. And of course, some good things just keep on keeping on.
We've had military developments such as stealth, low observable aircraft, smart bombs, things such as that. We have not yet gotten rid of the need for a heavy weapon hauler. And so in that sense, the B-52 is still applicable, and that's why it's staying around.
But it is flying in an Air Force whose operational envelope has stretched far beyond the reach of a bomber designed 40 years ago. It is now part of a much larger organization whose responsibility is increasing, even as its ranks diminish.
The Air Force of the future, I think, will be much smaller than the Air Force that Arnold knew or that Arnold's successors knew. However, the key is that with that smaller Air Force, to be able to continue to provide the nation the ability to influence events around the world, the only way we're going to do that is by continually exploiting technology and getting more capability as we go forward.
The scientists who participated in the new World Vistas study are the most recent of an organization which began when Dr. Theodore von Kármán and General Henry Hap Arnold recognized that in order to maintain the scientific superiority that was described by General Fogleman, the Air Force would need something more than the ordinary professional soldier.
Certainly at the time of von Kármán, there were Air Force officers who were fighting men, they were soldiers, and then there were scientists who at the time barely understood what military things are all about. Von Kármán put them together to make them talk to each other. But by doing this, he also created an infrastructure within the Air Force and a desire for pulling the scientific skills into the military force. So we have now a cadre of already a second or third generation of officers who are technically very, very competent. And it is no longer this business of we the scientists and they're the military guys.
In fact, at the instigation of von Kármán and Arnold, the Air Force now has its own Officer Corps of Scientists.
What would Hap Arnold have thought if he could hear you talk today?
I hope he would be proud. I think that Hap Arnold was a visionary, very unique person, very visionary. If you consider the time in which he lived, he was a brilliant man. He happened to be an aviator. He saw the need for thinking about the future in the 40s. And he created organizations to help him do that.
In Where We Stand, his summary report of Operation Lusty, published in August of 1945, Theodore von Kármán predicted that manned or pilotless aircraft would move far beyond the speed of sound. Rockets would deliver the means of destruction from great distances. Small amounts of explosives would cause widespread destruction. There would be target-seeking missiles for anti-aircraft defense. Supersonic planes would be necessary to penetrate enemy defenses. There would be communications between commands and individual fighters. Reconnaissance, communications, and navigation would be independent of weather and visibility. Airborne troops would be able to strike at distant targets and be resupplied by air. Most of Kármán's vision materialized or is nearing reality. In truth, recently adopted systems go well beyond it.
We have made a fundamental commitment to the airborne laser program. I mean, that has got to be seen as a leading edge capability. We have stood up a squadron for UAVs. We have awarded a contract for the development of a next generation UAV. We are operating UAVs in Bosnia. And in the information sphere, we're gaining more and more experience with space communications. We are linking space communications. Now you go from, the platforms to satellites to a ground station, to Washington, to the field. You link, you process, you feed the information back to the platform. So we're doing revolutionary things.
It's already a space force, isn't it?
In many respects, it already is a space force. We're developing a new expendable launch vehicle. We are putting up a new space-based infrared satellite system. So in terms of just the technological accomplishments of the last 6 months, I think that the lesson of von Kármán and Arnold about the importance of science and technology of the Air Force has been reinforced.
And in the next century?
I think you can see us making the transition from, the manned to the unmanned, to a much more complex use of information and space information and intelligence. So I think that's where we're headed.
You comfortable with it all?
Of course. I mean, you have to be comfortable with the future because you have no choice.
Hap Arnold retired here at his ranch near Sonoma, California in 1946, continuing an active interest in air power and its technology until his death 4 years later. Theodore von Kármán died in Europe in 1963. While both men were great visionaries, it's doubtful either could have imagined the ensuing effects of the high-speed computer or the many other developments that took place after they left the scene. But they would have cheered them on.